Okay, so I'm going to do a run through of all the questions in the review sheet. This way, if you didn't understand how to do some of them, hopefully this will help you. So the first question said on a standardized test with a normal distribution. So since it says normal distribution, we know we're going to use this curve. The mean is 85 and the standard deviation is 5. If 1,200 students take the exam, approximately how many of them are expected to earn scores between 90 and 95? So our mean score is an 85. I'm going to put an 85 here. Has a standard deviation of 5. So one standard deviation above, that means that the students would score a 90. Two standard deviations, they'd score a 95. Three, they would score a 100. And one standard deviation below is 80. Two would be, would be 75. And three would be 70. So we want to know how many of them are expected to score between 90 and 95. So between 90 and 95 would be 9.2% and 4.4%. So we need to add those percentages up. 9.2 plus 4.4, that would be 13.6% would be expected to score between a 90 and 95. Now what we're going to need to do is take our 1,200 students and multiply by 13.6%, or 0.136. So real quick, 1,200 times 0.136. And that gives us approximately 163 students. Number 2 says the mean age of entering freshman class at a certain university is 18 and a half. So 18 and a half is our center mean position. Has a standard deviation of 0.75. So that means one standard deviation above is 19.25. Two standard deviations above is 20 years old. So if the data produce a normal distribution, find the percentile of a student who is 20 years old. So 20 years old we found at 2 standard deviations. It's asking for percentile, it's asking for the percentages to the left of the data. So we want everything in here. We want to add up all of this area. When we add everything up to the left, that will give us our percentile rank. Quick thing to kind of make it go a little shorter, we know halfway is 50%, so anything here on is 50%. So we can just start at 50%, add 19.1, add 15, add 9.2, and add 4.4. Okay, so that student is at the, you can see it here real quick, is at the 97.7 percentile. 97.7th percentile. Percentile is anything to the left of the data. You just add up all of that, all of your percentages. The amount of time students work in any given week is normally distributed, so we're going to use the standard deviation curve with a mean of 10 hours per week, 10 goes in the middle, and a standard deviation of 2 hours. What is the probability that a student works between 8 and 11 hours per week? So if we went ahead and wrote out our standard deviations here, one above would be 12, 2 above would be 14, 3 above would be 16, 1 below is 8, 2 below is 6, 3 below is 4. It says between 8 and 11. Well, here's 8, and 11 would fall right here. So that's a half of a standard deviation above. So the probability, we are going to have to add these percentages here from 8 to 11. So from -1 standard deviation below to half a standard deviation above. Okay, so that is 19.1 times 2, since there's 2 of them, plus 15. And that gives us 53.2%. So the probability that students would work between 8 and 11 hours would be 53.2%. Okay, question number 4. Which correctly compares the mean and median of the set of data shown in the accompanying table? So this table here is a frequency table, measure and frequency. So we're going to have to use our calculator for this. Go to stat, and we want to edit our table. So we're going to put this in L1, 60, 75, 80, and 90. Then in L2, we are going to put our frequency. So our frequency for 60 is 2 of them. For 75, we have 4 75s, we have 180, and we have 3 90s. Okay, once your data is in, we're going to hit stat again, but we're going to calculate one variable of statistics. So your list is L1, your frequency list though, we need to make sure we put in L2 because that's what our frequency is. Our frequency is in L2. So second stat, we're going to scroll down to L2, hit enter, and then we'll hit calculate. If you have the older calculator, you're just going to put in L1, comma, L2 and hit enter. Okay, so it gives us our data. Our mean is 77, so let's write that down over here. Mean is 77, and we want to know the median. So the median, will scroll down, the median is 75. So the median is 75. Okay, the median and median are equal. No, the mean exceeds the median by 2. Yep, that's our one. These ones both don't work. Okay. Number 5 asks for the population variance of this data set. So once again, it's a frequency table. I went ahead and plugged in the data, but you're going to want to go ahead and do that. Once again, this is in L1, your frequency is in L2. Once your data is plugged in, stat, calc, one variable statistics, hit enter. We want our data is in list 1, our frequency list is in L2, so make sure L2 is in there. Then hit calculate. Okay, our population standard deviation is right here, 8.2. So our standard deviation is 8.2. But the relationship between standard deviation and variance is standard deviation squared. So we are going to need to take 8.2 and square it. 8.2 squared is 67.24, which is approximately 67.3 if you actually used this long value here, 8.20432937, and square that, that would give you approximately 8.3. I mean 67.3. So when we square 8.2, we get 67.2, which would be right here. 6, find the range of the following data. Range, pretty straightforward, you've been doing that for a while. Take your highest number, take your lowest number, find the difference. So your range would be 50. And 7's going to be the last one I'm going to do. Okay, it's some data here. It says you invested $380 in stocks. Over the next 5 years, the value of her investments grew, shown in the accompanying table. So let's make a scatter plot out of this. So real quick, I'll skip every 2 boxes. 0, 1, 2, 3, 4, 5. And I'll go up by 50, 50, 100, 150, and 500. So you want to make sure that you label your axes. So I'm running out of room on the bottom here, but this would be years since investment. Here will be value of stock. And we'll name the scatter plot. We'll call it maybe Gene's investment. Make sure you label, put a title, do all that good stuff. So now we'll just plot our points. At 0 it is 380, so approximately over here. 1 is 395, so that's about over here. 2 is 411, over here. 3 is 427. 4 is 445. Oops. And 5 is 462. Okay. So this would be our scatter plot. Make sure you do not connect the lines. Whenever you make a scatter plot, you don't connect the lines. The next part says to write the exponential regression equation for this set of data. Okay, so if we're writing exponential regression, we need to put this into L1, this into L2. So why don't you go ahead and do that now. This is in L1, this is in L2. I went ahead and already put that data in. So what you're going to have to do now is hit stat, calculate, and it says exponential regression. So we want to scroll down until we get to exponential regression. So hit enter. Your X list L1, your Y list L2, frequency list. This is not a frequency list. So this just doesn't represent any frequency, so we're going to clear that. We don't want that to be a frequency list. Hit calculate, and that gives us our equation. So I'm going to drag that into here. Okay. So here is our exponential regression equation. I'll rewrite that out. Y equals, and it says round all values to 2 decimal places. So A is 379.92 times B, which would be 1.04 raised to the x. Okay. Using this equation, find the value of her stock to the nearest dollar 10 years after her initial purchase. Well, x represents years, so that's what we're going to substitute 10 in for. So y equals 379.92 times 1.04 raised to the 10th. And that's what we're going to put into our calculator. So 379.92 times 1.04 raised to the 10th power. Hit enter, and we get, put that down here, $562, because it's set to the nearest dollar. $562. Okay, so I'm going to stop at 7 because 8 is similar. Just review your notes, this review sheet, and you should do okay for the quiz. Okay? Alright, good luck.